Okay, here we go. So we have the circuits. So let's start off with the first one that we have to learn. Ideally, I'd like to learn from a YouTube video first, because once you learn from a YouTube video, it's pretty easy to apply what you're learning, right? Because there's that element, like it's almost as if there's a teacher there to show you the reins, right? I mean, to hold your reins, like guide you, like nudge your head in the right direction, you know, so you don't get like distracted. So it's nice, it's nice. So here we go. We'll move this like here. Bitrate's looking good. Okay, so starting off with the week 4 content. So we need to be able to solve the basic diode circuits. So let's start off with diodes practice questions. So I'll go to YouTube. Actually, I'll Google it. This diode practice questions. Here we go. Let's have a look. Apparently there's something in chat, but I can't see the chat. Let me go to my stream and have a look. I wonder what's happening in chat, because usually I'm just streaming to 0 viewers, and that's okay. Tutorial. What was my YouTube channel? What is it? 4256. Okay, I can't see the comment right now. Oh, well, I guess I'll have a look at it later. I think it was just a glitch or something. Okay. Okay, so it's happening. So we know here the current goes through here, then it splits here and splits there. Then let me check the equivalent resistance here. 1/50 plus 1/5. Power minus 1. Okay, that gives us 4.55. That's what they got. Multiplied by the resistor here. And that resistor is what? Oh, okay, it's 50 ohms. not 50 ohms. The voltage here, which is 10 volts. So the current would be 10 divided by this. So I got 2.2 amps. I mean milliamps. They got 200 milliamps. Maybe because my answer is more precise. Actually, no, the voltage was 9.90. Okay. Now this is interesting. So they wanted to figure out the voltage going through the resistor 1, I believe. That's why they did V2 over instead, multiplied by voltage 1. So the voltage through here is the one that's going to be going through here. And then down here we're not 0 volts, so there's 0 volts here. Okay. It's interesting. Okay, here I have 10 volts going through here. Since it's positive, this when it goes through here it's on. So it can't go through here, it's off. And then it can't go through there. And then it goes through here. And it goes through there. So that's what the first part it can take. But I'm not sure if that's the only consideration we have, because if we now go from diode 3 to this diode, actually there was a rule for a diode to be activated. The potential at diodes will only activate if the left potential is higher than the right potential. So wait. Actually, let me go to YouTube and follow like a tutorial, so I don't lead myself astray. Left. What was it called again? Diode and basic diode circuits. And any conventional circuits. Diode clipper circuits. So I don't need these parts. Okay, so assuming the diodes are ideal, find the output voltage for the given circuit. Okay. So just draw this as a part. Current can go through here. Okay, we'll go through the 100k resistor, and it won't go anywhere. So this is will be like there's an open circuit here, and then it can go down through these two 10 kilo ohm resistors. It can go through this resistor right here, and then the second resistor. This is connected to the source, and since this diode is here and it's negative, there's two sources. I'm just going to assume this is off for now and keep this off for now, and then use superposition to solve it later. So I'm doing just for this one, and because we have a diode here, I'm assuming it's an open circuit here. So 10 volts. And so once I have drawn the circuit, I can get rid of the diodes because I can just treat them now as wires. And so I'm asked to find the potential at VO. Okay. So I have a current I that goes through this circuit here, a current that branches off here, and the current that branches down too. So I have I1, I2, and I3. So this is I1 going here. I3 is the one that goes down, and I2 is the one going here. And if I write the KVL equation, so minus I1 plus I2 plus I3 is equal to 0. And then I can solve this, I think. So I know that, so let's simplify the second. Not sure if I simplify this part, the voltage between these two should be the same, right? Now I'll simplify it and see what happens. So I1 is equal to 10 volts divided by R total. So R total is, we have 1 over 20 plus 1 over 10 to the power of minus 1, right? And that gives us an equivalent resistance of 6.667, or simply put 20 over 3. So that's what I'll stick with. So I'll do 20 over 3. I mean 10 divided by 20 over 3. That will be our value for current. Oh yeah, and it also has to be negative. And then I1 will be 10 volts minus the potential, oh my goodness, minus the potential here. So I'm just going to leave that as a node. So this is our first node, V0, and V0 is equal to 10 volts, and V1. Okay, so yeah, it will be 10 volts minus V1 divided by the 10 ohm resistor plus 10 divided by 20 kilo ohm. I mean, I say ohms, but they're all in kilo ohms. So if I solve this expression, so I'll start off with simplifying what can be simplified. So 10 divided by 20 over 3, that is the same as 3 over 2. So minus 3 over 2 plus 10 volts minus V1 over 10 ohms plus 10 over 20. What does that simplify to? 10 over 20 should be 1 over 2. Okay, it's equal to 1 over 2 is equal to 0. So we now need to get the denominators all the same. So we need to multiply all of these by 10. So 10. So now we have 10 multiplied by 0 is obviously still 0. Then here we do 10 divided by 2 is 5, multiplied by 3 is 15. So I have minus 15 plus 10 divided by 10 is 1. So this is just 10V minus VI. And what did I write here? Oh, okay, plus okay, so same thing here. 10 divided by 2 is 5, so plus 5. So now I collect the like terms here. So minus 15 plus 15, so minus 15 plus 5 is equal to 10 plus 10 volts minus VI. Nope, I've made a big mistake. I can't get my answer as 20 volts is equal to VI. Yeah, that's not right. But I wonder if it's because I combined these two resistors. So I think the correct answer should have just been I ignored this part because the potential here is 0. Then I take the potential here, so I didn't need to combine them in series. So let's see what the answer is if I don't combine these two resistors in series. So that would have obviously stayed as 10. 10 divided by 10 is 1. Let's see. Let me erase this. So I would have gone in minus 15 plus okay, so we have 10 volts, right? We add that to the 15, to the negative 15, that gives us minus 5 plus 1 is minus VI is equal to 0. Add that here. So I have minus 4 volts is equal to V1 or VI. So I got minus 4 volts. They got positive 4 volts. But I think the difference is I just said current entering the node are negative and current leaving the nodes are positive. And I think that's how I got the answer. Minus 4. Let's see if it's correct. Nope. Nope. I got the answer wrong. Oh well. What can you do? It's trial and error. You get some right, you get some wrong, and I forgot to include superposition as well. Okay, let me try this again. Okay, I think the best way now is not to learn everything, is to learn how to solve the solutions. So I'm going to look at the tutorial solutions for each question that pops up in the practice, and then try to answer it based on what they did in their solutions. Okay, let's get started. I'm trying to pull up some content. Let's see which week content pops up. Okay, I just realized the quiz is fully open book, so I can use my laptop. Hmm. So I need to figure out the current that flows through this diode. So I have a 10 volt source. So I have 10 volts here. 10 volts goes from here. I have a resistor here. A diode. It's 5 ohms. So this diode is conducting when it's positive. Then there's a short circuit here. Then this diode is conducting. Bam, bam. And then it branches off through here and there. Since this is not conducting, there's like a short circuit. So bam. 9 ohm resistor connected to nothing. So the potential at 1.0. Then the 15 ohm resistor. So so I have one current here. I1, then I have a current here, I2, I3. So I1 is the original current, so it would be minus I1 plus I2 plus I3 is equal to 0. Minus I1 is equal to 10 minus VA divided by 5. Plus I2 so I2 is equal to VA minus 0 divided by what resistor was this? Divided by 9. And I3 is equal to VA minus 10 divided by 15. and this is equal to 0. And now I need to figure out what VA is. To do that, I need a number that goes into all of them. So I do 5 times 9 times 15. 6, what was it? 675 divided by 10. Divided by 5. It gives me 135. 135 times 10 minus VA plus divided by 9, 75 VA plus divided by 15 equal to 45 VA minus 10 equal to 0. 135 multiplied by 10, 1350 minus 135 VA plus 75. So this would be minus and this would be positive. 75 VA plus 45 VA minus 450 is equal to 0. Adding like terms, we have minus 1350 minus 1350 minus 450 minus 400 minus 1800 plus 135 plus 75 plus 45. 135, 75 plus 45 plus 2255 VA is equal to 0. Moving terms, so we have 255. VA is equal to 1800 divided by 25.5 by 20.5. VA is equal to 1800 divided by 255 is equal to 7. Now that's not the right answer. Oh wait, no, this is 7 volts. So 7.06 volts. Now to figure out the voltage we're going to here, we now just substitute it in 7.06 volts. What was the expression? 7.06 volts minus 10 divided by 15. And let's see if we get it right. Answer minus 10 by 15 gives us minus 0.2, and that is not the answer. So let's see. What did I get wrong? So the top right diode is pointing right. Okay. Will conduct if left side is more positive. So bam, bam. So it goes from 5. Okay. And then vertical diode will conduct if bottom is more positive. So it doesn't go through there because the top is a higher voltage, right? So they're saying it goes to 10, and this one does not conduct. So it goes from 10 volts to 5, and then from 5 it goes to here, skips this resistor to 15. So that's what they're saying. So the to 0.5. So they're saying when it goes through here, we have 10 volts, right? That is our positive potential at the node VA. And then when it goes to the node VB, we have 10 volts divided by 5. That gives us a current 2 times 9. Wait. 10 divided by 5. V is equal to IR. That's 2 ohms. Okay, it can't be the pixel, but VB is less than VA, so I is equal to 0, and that's why it doesn't conduct there. And the potential here is -10. -10 is less than VA. Okay, there's no that here. And then goes through there. So what can I say? So 10 volts is equal to VA. VB is less than VA, so it cannot conduct through there. And here, so it goes through the 15, so 15 okay, so when we get this, we have a simple circuit. So the circuit now, we have a 10 volt source. The 5 ohm resistor goes through there. It doesn't go through there because it's not conducting. Again, same story here. The potential is not high enough for the current to flow that side. So it goes through the 15 ohm resistor. So now we need to figure out the total of current in the system. And that's easy. We do 10 plus 15 plus 5, which gives us 10 over 20, which is equal to 2 amps. Now that we have 2 amps, we need to figure out the current that is going through this resistor. So find out the current that goes through this resistor. So what happens here is we have 2 multiplied by 10. Wait, what did I say? So 10 divided by 2 is not 2. It's half. So, okay, now time to go to my notes, see if I can find this question. So week 4. This question up here. Okay, I have this question on my week 4, but why is the quality so bad? I think I'll download this and then try. What they're saying, we need to make a Thevenin equivalent circuit. So we need a circuit with a single resistor and single capacitor. So just focusing on the resistors, they're in parallel. So our Thevenin should be 1/400 plus 1/200. Answer -1. That's to give us 133. But where did I get 100? Okay, so for me, that gives me 123. For this circuit, where was the R Thevenin? So let's see. If we calculate it the same way, we get a similar answer. 1/100. Nope, not the same answer. So they wrote the I don't know where they got Ix equals 1 from. So they have Ix equal to -1. Okay. Let's see what it's saying. So it's saying there are two nodes here. We have node A and node B. So I'll get started. A and node B. 400, 2, 2, 5, IX. So they're saying we need to write the queso expression at the second node, because that is where the current is flowing. So the current flowing to the resistor is IX. So this is equivalent to A minus B divided by 200 is equal to IX okay, and then I mean not 200 here, it's 100. It'll be minus 100. I mean A minus B is 100. Is the voltage at, I mean it's the place here at that part, and for here we have 5 IX X is equal to okay is equal to V. I mean it's equal to A divided by 400 plus A minus B divided by 100, right? And now we substitute everything and solve it. So we have 5 A minus B 100, right? is equal to A over 400 plus A minus B minus 100 actually can make this like so. So now we need to simplify it. So if we multiply everything by 400, I think that should do the trick. So that gives us A plus 400 A minus B Okay, so wait, I made a mistake. We don't need to do all of this to figure out what A or B is, what it's telling us. So we multiply this by 100. So that's saying 5ix is also equal to A minus 400 plus ix is the same thing. So that's saying if you do this for ix, it's equal to A 400 multiplied by 40, this by 40, and by 400. Go to 1600 ix is equal to A. Since we have A, we can now substitute it here. So 1600 ix minus B is equal to ix, these two divided by 100, of course. 100 multiplied by ix is equal to 100 ix subtract 100 ix, we have 1500 ix is equal to b. And next, to say the capacitor is equal to Ix is equal to C Ci 2. In our case, this would be Ix is equal to 2 microfarad multiplied by IT, which is 1500. 15 just 1500 Ix see, they just wanted to see it for now. Sc is equal to 1500 Cix Ix definition of a capacitor got out. X is equal to C dV2 over dt then dt2 over dt is equal to in this case it's 200, in our case equal to 1500 ix. This is equal to, no, it's 15 so it becomes 1500 dix over dt. Okay, so we have to substitute the capacitor, well, to C times so Ix is equal to 1500 C dix dt. This is where thought the derivative should the shouldn't the derivative be Cool.